All right, good evening, everyone. So today we are going to look at AWS security and encryption, right? So why would you want to encrypt your data, right, or protect your data? The main reason is that you would want to prevent what we call a man-in-the-middle attack, right? So what is a man-in-the-middle attack? Let me bring the annotator, then we are going to do it, right? So SAA has some data, right, that they would want to send to who? They would want to send to ALX, right? And there is somebody, right, an attacker or whatever it is, that might intercept the message, okay? So what you want to do is that you don't want a man in the middle to intercept this message and then read what it is or know what it is, and then they will use it for their own exploit. So SAA would want to what? Encrypt this message, right? This is padlock. Okay, encrypts the message, send it, and then the recipient will now be able to decrypt, right? Open the padlock and then see the content of the message. All right. Now let's come into practical, like our real world example, what a man in the middle attack is. So, recently there are Momo frauds, right? And then most of the frauds, what they do is that they call you and Obibeka so, chairman, misikano. You understand? Then do like my boss had encountered stuff like that before. So he had a conversation with somebody on phone, right, about some work to be done. And then he was supposed to send, I think, 30 CDs or so to the person to buy some materials and then all that. Now, when he left the place, another person called that, boss, Sikano, you understand? And because he had had a previous conversation with somebody on something like that, he didn't even bother to ask, okay, that why those things, because he had previously had a conversation like that. He was like, oh, okay, then let me send it to you now, right? And obisa number no and or send it later as or send it sikano. Then the legit person who was supposed to get the money to buy the stuff called him. You get it? Called him that, chairman, my do shop, because the in common was that with your shop or whatever the amount will be, let me know, right? And whatever the amount will be, let me know, and give me the number of the vendor, right? And I'll send the money. When back on a friend, no, the same thing that was my vendor number, no, and I'll send it, right? So that is how man in the middle attack works. So the message will be intercepted by somebody. We have call redirect and then all those things. Those of you who watch the, most of the CIA movies and then all that, these things, or crime movies, these things happen, right? Some robbery might have happened. Somebody would want to call the police, and then somebody intercepts the call and then redirects to another place, right? This is what we call man in the middle. So you would want to encrypt your messages, right, to protect these from these attacks. So even if the message is being intercepted, the person will not be able to, read the details of the message. Right. Now, how does encryption work? I think the drawing explained it, right? So the message will be encrypted before sending, and then it will be decrypted after receiving. Okay, and then it works both ways, both server side and then client side. So server side is when the whole thing is done. So in the context of AWS, the whole thing is done in AWS. So if you are sending maybe a message from one server to another server, the server will encrypt the message will be encrypted at rest, right? The server will send the message to the next instance or the next server, and then the server will now use the same key to decrypt it. All right, that is encryption in transit. And then at rest is when the data is encrypted when it is not moving. All right. Now we have something we call TLS certificate. So if you open a website, right, and then you see HTTPS. Most of us don't pay attention to that, but let me try, and then I think I have some websites open. So quickly we can check that. All right, so I'm on Udemy right now, and then if I double click, you should see HTTPS here, right? So the S here is just for secure, right? And then this is made possible by what we call a TLS certificate, right? These ones help in encrypting our messages also. That is the connection that we have between web servers, right? Because you might have personal information, you have your email, you have your password, and then all those things there. So when we say interception or man in the middle, that is how it works. You would want to visit their website. So these online hackers or spammers, right? You might see a website that looks like Facebook, right? You would log into the website, you type your logins and then all that, and then those logins will be stolen, right? For now, and then they will now have access to your Facebook logins itself, and then they use it for their own personal stuff, right? So that is just explanation of man in the middle. So this is also a diagram on the thing what I explained, right? So a user would want to connect to a website. They visit the website. So I type www.console.aws.com, right? And then I'll have to enter my username and then password. So immediately I enter that, this client will communicate with the server. So these logins will be sent as an encrypted message here. And then when it gets there, it's now decrypted and it will be able to read the information. If it is correct, you are logged in. That is just how it works. All right. So I spoke about server-side encryption. So this is the encryption at rest. So with at rest encryption, the data will already be encrypted when it is not moving, right? And then with the same key, right? We'll talk about the encryption key and then all those things as we move forward, right? So the data will be decrypted before sending, right? So when it's sent, then whoever, whether it's a server or whatever is receiving the resource, will also receive it and then encrypt the data back, right? Again, with the same encryption key, right? So this one, you use a service like S3, right? With S3, your data is encrypted at rest. Please do well to intercept when if you have any question, right? So I also explained client-side encryption. So with client-side, the server does not know anything about the encryption key. So you have to encrypt it yourself, send it wherever you are taking it. And then if you want to decrypt the message, you will have to also decrypt the message on the receiving side, right? So for that, the server doesn't know anything or doesn't see anything about it. So I would want to, let me see if I can recall a typical exam question. If not, let's just move on. Right. So the service that enables us to encrypt or decrypt our information or data is KMS, right? So anytime you hear encryption, then it is a service in AWS. It's made possible by the KMS, Key Management Service. And then it is fully integrated with IAM for authorization. It gives you an easy way to control access to your data, right? And you are able to also do an audit on the key usage through CloudTrail, and it has integration with a lot of services: EBS, S3, RDS, Systems Manager, a lot of services actually, right? So there is a security advice or best practice that you don't store your secret in plain text, especially in your code. So, sometimes when you are the app developers, you would want to store some codes and then all that. You don't have to store them in plain text. You encrypt them, put the encrypted message there, and then you will have to specify the keys that you would want to use to, encrypt it. We can't do hands-on because it's going to take a lot of time. So for the hands-on, I think now everybody should have the videos now, Stefan Marek's videos now. So you can watch the hands-on on how to encrypt and then decrypt your data with KMS. Right. So there are two types of the KMS keys. You have the symmetric, and then we have the asymmetric. Now the symmetric is when you have just one key for the encryption and then decryption. And then the asymmetric is when you have two keys. You have a public key, right? And then a private key for decryption, right? So if you are using a symmetric key, then when your data is encrypted, you have the public key for receiving the encrypted message, right? And then you have the private key to now decrypt the encryption to see the real message in plain text, right? So if I have a message like hello, right? And then I encrypt it, then it can be, so if it goes into encryption, we can have some, blabberish words, right? This is the encrypted message. Now you will use the encryption key or the public key to receive this, and then to see the text itself, you need what? The decryption, the private key, right? To decrypt that message. So that's basically what it is for asymmetric and then symmetric. And then the symmetric is mostly used by AWS services, right? So when the communication is between two servers, so let's say two EC2 instances or an EC2 instance and an S3, right? Then symmetric keys are used. So the same key that is used to encrypt the message and then sent to S3 is going to use the same keys to decrypt it, right? And mostly you would want to use asymmetric for encryption outside of AWS, right? For users who can't call the KMS API. So if you are sending a message to somebody outside AWS, they don't have an AWS account, then you might consider using a symmetric key. So you will be given a public key and then a private key, right? And then you give those keys to the person to do the encryption and then decryption, right? As to how what goes into encrypting and then decrypting, as I said, you can watch the hands-on, but most of these things you just have to have an idea of how it works, and then you'll be okay, right?
Now I want to know if everybody gets the explanation for the public and private.
No, so
I just want to know if everybody gets it.
Okay, so since you asked, let me talk about it. But then, no, it's not anybody, right? For public key, what's it called?
No, like the question I'm asking is everybody on the call. I hope everybody on the call understands the two.
Okay.
The public and the private.
The private key.
Yeah.
Okay, if you want to ask,
But say they all kind of know. Don't take people. I don't know if they go back. Like it about.
Yeah. Okay,
but
so
if everybody gets it, then
okay, so let me try and then explain what public. Let me use a real word as an example. Okay, so let's use. So say you want to attend an event, all right? You want to attend an event, and most of the times is when you watch movies, you will go there, they will ask you for a phrase, and then they will ask you what's your number, right? So the phrase could be your public key. Or let me use even the army. You see, the army have some coded language that they speak. So these are the language that they sometimes use to the friend saying, identify people who fake to be, military men, right? So they see you, probably you pretend as one, they will say something and then unye, right? So the public key could be just the uniform, the fact that you are wearing a uniform, or the usual ahoya that they say. But see, there are some technical stuff that they say, or military terms that they say. If you are not a military man, there is no way you would know that. All right. So, and then this whole public and then private key came from that idea of the military communication. It started from Morse code. So Morse code, they communicate in sounds, right? So the how you play the sound will determine what you are trying to communicate. So the public key could be like the usual stuff that we all hear, and then the private key will be those technical ones that you will have to know as a military man before. I mean, you will be able to communicate as a military man. So that is basically public and then a private key. And then the private key is always encrypted. So the private key will also come to you encrypted, right? And then you have to retrieve that private key through decryption before you use it to decrypt the message itself. All right. But I think everybody understands since no question is coming. Okay, so these are some pricing and then what have you. So there are also types of KMS keys, right? There is AWS owned keys. So the owned keys are, so when you are creating an S3 bucket and you see KMS, server-side encryption by S3, those are AWS owned keys, right? So SSC S3, SSC SQS, SSC DDB, you have SSC what, like a lot of them. But anytime you see server-side encryption and then the service name, then it means it is owned by AWS. And then there are AWS managed keys. So the managed keys, you will see AWS slash the service name. So here you see AWS slash RDS, AWS slash EBS. Let me go into the console and see if I have some keys there already. Okay, so if I go to AMS, okay, so we have managed keys. So sometimes if you have used any of these services before, you should have these things there, right? And then you enabled keys. What's it called? Like encryption by KMS. You should have some of these. So you see, this is AWS. So you can see AWS managed keys, right? The AWS own keys, you don't see them. You don't see them because those ones are owned by AWS. So those ones there, you will not see them anywhere. But you'll be able to see the managed keys. So you can see this one, this for the EFS system, this for AWS backup, this for the EBS, this for RDS. So as you continue to use these services and then you enable encryption, right, by KMS, you should have the rest of them generated here. And there is also customer managed keys. Currently, I don't have any managed key. I've not created any key. Those ones you create it by yourself. And there's also AWS Cloud HSM keys, right, for external key stores. But this one is out of scope for the exams too. We can chillax on that one, right? And there is also key rotation by KMS, and then it's done every year. For that one, you cannot reduce, you cannot make it less or more, but the keys are rotated every a year. So it is an option that is enabled, and you can make it less or you can make it more. And there is customer managed keys that I've spoken about. You can enable that one, and then also yes, it's rotated every 1 year, right? But you can also import your own key. So you can have your key outside AWS and then you can import it, right? And then for that one, definitely you have to manage the rotation yourself of AWS, right? So for a customer key that you create, you'll be charged $1 per month in KMS. And then for a key that you import, it should be a symmetric key. So it should be one key for both encryption and then decryption. You are also charged $1 per month. And then plus you pay for each API call, right? For 0.03 cents, like 3 cents per 10,000 calls. So this is an example of encryption and then decryption. Sorry, how to copy files, right? So here is EBS snapshot, right? So one single key cannot live in two AWS regions. So if you want to share, let's say an EBS snapshot cross regions, what you need to do is that when you create the snapshot, right, and then it's encrypted, it will be decrypted and then sent to the other region. And then when it comes to the other region, it will be re-encrypted, and then now you can create the volume out of it, right? So you can see here, the key is changed from key A to key B. However, there is a case of multi-region keys that we are going to get into. But the usual thing is that a single key cannot stay in two regions, right? So we come to KMS policies. So KMS policies are like resource policies, right? Just like the S3 bucket policies that you create, right? So the default key, there is a default key policy that is created. That is if you don't provide a specific key. I think we'll go into that one. Hey, no, this $1 I will not pay. Right. So if you don't specify a key policy, then there will be a default key policy that allows complete access, right, to the root user and then the entire AWS account. However, you can create a custom key where you will define the user and even the roles that can access the KMS key. You can define who can administer the key. You can also use for cross-account access of your KMS key, right? So if you have something, a resource that you would want somebody else to access, or you are sending message across to another AWS account, or you are sending data across another AWS account. So for example, in the case of the EBS volume thing, right? If you are sharing the volume with another account, then, or let's use AMI, right? If you are sharing an Amazon machine image with another account, then you should specify a policy that allows that account in the the other accounts to access the KMS service and also access the KMS key, right? So if they don't have the KMS permissions, they wouldn't be able to probably decrypt whatever you sent them, right? So this is how a policy is like when you are copying a snapshot across accounts, just that I spoke earlier. So you first create the snapshot account, you encrypt it with your own key, that is a customer managed key. You attach a KMS key policy to allow cross-account access. So you are allowing the other user to, access it, right? And then before you share the encrypted snapshot. So in the target account, that is the account that is receiving the snapshot, we'll create a copy of the snapshot and then encrypt it with a customer managed key in my account. So the accounts that I use to encrypt the person will use the same account to create a copy of the snapshot, right? And then the person will now create a volume from the snapshot. All right. And then this comes the case of a multi-region key. So for multi-region key, here they are not original keys, they are replicas, right? So the original key or the primary key itself stays in one region, and then it is replicated across multiple regions or across regions. So this will enable you to use the same key, right, across regions where you have your infrastructure or where you have deployed, other AWS services. Okay. But there is a downside to using multi-region keys, right? There's a downside to using multi-region keys. We'll get into that as well. So yes, if you have an identical key in multiple AWS regions, then you can use them interchangeably. All right. So they have the same key ID. Every characteristics or every attribute of a key will be replicated to the other region. And then the use case is that you can encrypt a message in one region, and then you can also decrypt it in another region, right? And then you don't need to do re-encryption or making any cross-region API calls. So like the situation of the EBS volumes, you don't need to, when it is copied or when you share a resource to another region or another what's it called, account in another region, you don't need to re-encrypt it with another key. You can just decrypt it anytime you want because you are using a multi-region key, right? And as I said earlier, they are not like, it's not like a global key that it's one key that you are using all around or across all the regions. What you are doing is that you have your key somewhere and then you are creating a replica. So those who are into the football fans, right? The original jersey stays with the team, but there are replicas across the world, right? There are replicas that we still call original, that we still call original, but which are not original. So if you want the original jersey, then it stays with the team, right? The ones that the players wear, but you have like different brands of it, right? I mean, different copies of it all around so that Ubia Benyibi. But the original one itself stays at one place. All right. And then each key, each multi-region key is also managed independently. All right. So the use cases are when you have a DynamoDB, like a global DynamoDB table or a global Aurora table. So, for global DB tables or the global services, you are having it across regions. Okay. So you don't need to use a single key. Using multi-region keys is best in this scenario because what happens is that if maybe you created the table from US East 1, and then you encrypted a certain type of data. So you don't use it to encrypt the entire table. But let's say there is an ID card number, there is a social security number, there is maybe a bank account information, a credit card number in one of the rows or columns that you created, right? Depending on the database that you used. You can use a multi-region key to encrypt that particular data in a particular table. All right. So even with this, you are able to even prevent access. I mean, your database administrators access to that information. So anybody, any client who would want to access that information need to use that multi-region key if they have the permissions to use it to decrypt key, then they will be able to decrypt it. Right. So let's say in cases of user passwords, right? Some of the applications, when you open the account, you don't, even though it's your own password, but you see it in dot dot dot. So if you want to see it, then let's use Google Chrome as an example. So now the Google Password Manager works in a way that you are able to save your passwords in the browser. Now, if you want to view that password, it will require you to, do some authentication before you are able to view the password. So this is how it works. So the case of the DynamoDB global tables, and then yes, the Aurora will be the next one. So a client puts an encrypted attribute. So this is a table, right? And then in the table, there's an attribute that has been encrypted, right? So you can see here, these are just illustrations anyway. So this data is encrypted. This is the entire table, but there is an attribute in there. So here it is using SSN. So I think social security number, right, to encrypt the data. Now the table is replicated to AP South East 2, right? And then you can see the attribute is still decrypted, right? So the client should be able to use the multi-region key via KMS to be able to decrypt the attribute to see what the real values are. right? So that's basically about multi-region keys. So this is the same thing for Aurora as well, right? So in Aurora, that's a relational database. So that one you talk of, your data is in columns and in rows. And then in DynamoDB, there are no SQL or non-relational database. So you talk of what? Attributes, right? Please, any question? All right. So let's look at S3 S3 replication, right? So when you are using S3 replication and you encrypt with a customer managed key, it means that there would be a decryption, like an encryption and decryption, like all the time, right? So it means that the KMS service will be called like multiple times, and then you have what we call throttling errors, right? It means that like there you might exceed the quota of how many API calls that you can make to KMS. Okay. But then even though you can request for a service quota increase, but then there is a recommendation that you use a multi-region key so that it will reduce the number of API calls that is made to KMS. But then, since they are still treated as independent keys, the object will still be decrypted and then encrypted. But then that reduces the cost to what's it called, the KMS API. Okay, so that is basically it. So because if you have a customer provided key, then there's always has to be a call to decrypt, encrypt, decrypt, encrypt, because the object will be encrypted at the source. It will go to the targets, it will be decrypted and then re-encrypted. So you can see that there will be a lot of like requests to KMS, right? So yɛmfa also anyway into a trip. Okay. All right. So the same case with AMI sharing. All right. So if you are sharing the AMI, I think when there was a lab on, I think it was the same lab, controlling access with IAM, where we created multiple users and then we have to create an AMI, send it to another region, right? And then now launch from there. But you realize that when we were doing it, there were a lot of things that, yes, when we were even sharing the AMI across the region, we're supposed to add an IAM role. So a lot of people had that problem. They created the EC2 instance, but then they weren't able to. There was a problem like that, and the issue was the fact that the AMI didn't finish, like it wasn't completely ready before they before it was replicated or shared across region. So in that sense, people had issues with their EC2 instance that was launched in the second region. So what they needed to do was to delete the AMI, delete the instance, and then create the AMI again with the IAM role and then send it. And then that was what was working background, right? There was a KMS key that was created. So the IAM role or the user in the target account must have the same permissions to describe the key, re-encrypt, create grant, and then decrypt the key before launching that instance. So that was what was just happening, right? So that is also the use case, another use case for multi-region keys. Now, please, any question? We are moving on from KMS. All right. So we've all been using parameter store, right, for our RDS, the database. So basically, parameter store is used to store parameters for our services, right? In services that we are creating, especially in our case, we've been using it with RDS a lot. So what you do is that you put those parameters in the parameter store, and then so if it is RDS, you give RDS that role or that IAM role to be able to query what's it called, credentials, or always call the credentials from the parameter store to you. So you create your database with a username and then a password, right? And then with the you go to the parameter store and then you store the endpoint, the username, and then the password, and then the database name as well, right, in the parameter store. Now, what is happening under the hood is that anytime you call the SQL service and you are trying to log in, you enter your details, the username, the host name, and then the password. What the RDS service does is that it goes to the parameter store with the right IAM permissions to retrieve those keys or those credentials that you entered, to match it up to see that, okay, they are the right information that you entered, and then you log in. So that's basically what happens. And then, yes, it is also made possible. What's it called? There is an option for you to store your credentials as secure strings. That one, I think, for parameters, I think those ones is free. So let me just go into. So here you can just search parameter, but the service is by SSM, Systems Manager, anyway. Right? So Systems Manager and then parameter store. So I won't create a parameter though, but I just want us to demonstrate the secure string. All right. So here you can see you can create a string, you can create a string list. So for string lists, these are all on a encrypted parameter values. The interest is secure string, where it works with KMS. So you can see we can use a key source from the current account, right? And then we'll use the default KMS key for this account or specify a customer managed key for this account. So if we are using a KMS key, then here, so what is that? What is this type of key? Right? This will be a managed key, an AWS managed key, right? So is the key alias. So if I had created a key, then that is a customer managed key, right? If I had created a key, then it should be the alias or whatever name that I give to the key. But since if I want to use an AWS managed key, then I'll use this one as the alias /AWS/SSM, right? And then I'll store the value of my parameter here. So I'll say this is test, right? And then I'll create the parameter or parameter name test, right? And create. Okay, so if I should open this, you can see that the string would be what? Encrypted. The usual string that we create for our RDS, normally we don't save it as what? An encrypted a secure string, right? So here you can see it is encrypted, so I won't be able to say it. But because it is the same account, I have the same account, so I have the permission to also decrypt it. So I'll just select show decrypted value, and then it will give me the value of the string that I created. So if it is another account, then that account, or what if it is a service, then that service should have the right IAM permissions to decrypt that. And then the permission would be a right permission under the KMS service, right? Right, yes, it will be a right permission under the KMS service called decrypt. Let me just go to IAM and then we'll see that. So I'll just add it to a role. I don't know if I have a role in there. Okay, so I think I have a lot of roles. So this one is something that I created here, right? So here I can add an inline permission, sorry, an inline policy, right? So the service will be KMS, and then the actions, it should be a right action, right? So if I want the person to be able to decrypt it, then there should be decrypt. So you can see decrypt, and then encrypt. So these are write permissions, and I can also add. So I'll add describe key, right? And then probably gets public key. So if I have these permissions attached to this role, it means that any identity or resource that will resume this role will be able to what uh decrypt any encrypted message that I was sent. Okay, so that is about it, but I won't create this one, so I leave it. All right, so you are also able to get notifications, right, with event bridge. So probably anytime there is an API call to the parameter store, you are able to generate notifications to event bridge that you can also integrate with SNS so that you receive the notification. You can also integrate it with CloudFormation, right? So in creating your CloudFormation stack, it's integrated with CloudFormation to be able to access the same parameters as well, right? So with parameter store, these are the hierarchies that you can. So normally what we do is that we just do probably db slash endpoint, but you can actually store it in a hierarchical form. So in this example, it has what my department as the parent directory, and then there is my app, and then dev. So this one has like what's it called, two environments, right? A dev environment and then a production environment, and they are under my department. So let's go back to parameter store. So in the parameter store, so I can have what directory. Yes, I want to put something. Sorry, the name. So for in that example, we can have my app slash dev, right? And then slash db let's say URL, right? You can have something like this. Usually what we do is that we have db slash URL, db slash endpoint, db, but you can have something like this, right? And then you are able to integrate it with Lambda. So you can write a Lambda function to get these parameters. Okay, you can configure a Lambda function to get these parameters. So here, the Lambda function should be able to get the parameters or get the. So if you are using a get parameter by type by path, let me explain this. To get parameters by path, what you are saying is that you are able to call a function to get the parameter by path. So instead of specifying db dev slash db URL, you can just do my app, right? So in your function anyway, you can do my app, right, slash dev. You know, this one is even, you can do something like this, my app, right, and then you do slash, right here. When what you are doing is that, and then you can add what you call a recursive flag. So what this will do is that it will retrieve all the parameters under this part, or you can do my app slash dev alone, and then it will retrieve all these for you. All right, so it's just a high level overview. They are not going to ask you what's it called, how do you call a function, and how do you call parameters in the parameter store. uh I mean, the code that you write, but they can ask you how to maybe a lambda function to retrieve maybe recursively. So what you do is that you use the get parameters by path API or the get parameters. So if you are using the get parameters, then you make sure that you specify the full part of it. So dev my app/dev/db URL, my app/dev/db password as well. All right. If you want to do it by part, you can even just do my department and then /star, and then you will have a recursive, all these departmental, all the parameters under the department will be retrieved. So the same way, the Lambda function should have the right IAM rows to read the decrypted message, or to decrypt the message and then give you the message or the data or the credentials in what? In a plain text form, but not the encrypted one. Once again, there is a hands-on this one in the video, so you can also watch that one as well. If you will say we'll do it, it will take a lot of time. All right. So, and these ones are bonus secrets, right? So you are able to even write a function for Lambda to get you the latest AMI, right? So if your Lambda function, you have written a Lambda function to launch an EC2 instance or to run updates, you can specify something like this, right, in a parameter store for the Lambda function to call to check for the latest AMI, the latest AMI in the list of AWS AMIs. And this one will also be able to get parameters from secrets in a secrets manager. You can get a secret ID from AWS Secrets Manager. So these are like paths or credentials that you can store in parameter store and integrate it with your Lambda. So parameter also have 2 tiers, standard and an advanced. Once again, let me go here and then we'll use that to create that. So this is it. So you have a standard tier and an advanced tier. So for standard, you have up to 10,000 parameters, right? And then the parameter value size can be up to 4 kilobytes. And here, the advanced, you have up to 100,000, right? So that's why it says more than 10,000. And then a parameter value size can be up to 8 kilobytes. And then you are able to create a parameter policy, right? But then there are charges that applies. Okay, so here is only the default parameter policy. You don't even set any parameter policy, but if you are using the advanced, you are able to set parameter policy. And then it is free for the standard, but there is a charge for every parameter. That is 5 cents per parameter per month, right? So these are example of parameter policies for advanced, right? Where if you would want to rotate your parameters, okay? So you can have an expiration, a parameter expiration to delete a parameter, and then you can have an event bridge notification to notify you 15 days, right, before your a parameter expires. And it is only for advanced anyway. It is only for the advanced. And then you can also, if you don't want it this way, you can set a parameter to probably notify you that, okay, you've used a parameter has been used for more than 30 days and it needs to be changed. You can have all these, right? So secret manager is just like the parameter store. But what secret manager does is that it gives you automatic rotation, right, of your secret, and that one you can set for a number of days, right? There you have the flexibility of choosing the rotation of your keys, unlike parameter store that you need to have the advanced tier, right? But secret manager has it, for you to even give you the flexibility of rotating your keys, right? And then the rotation, it automatically generates this secret on rotation. So if you have your RDS taking the credentials from secret manager, all you can do is that you can set the number of, days for expiry for it to rotate these credentials. And then automatically your database, your RDS or your AWS service is going to integrate or recognize those credentials automatically. So let me go to secret manager and see if it is something that Yes, so easily rotate, manage, and then retrieve secrets throughout their life cycle. So yes, I won't create it. But then there's a 30-day free trial. So after creating a secret, I can delete it and then I'll still be within a free tier. So let's see if you want to store a new, so you can see credentials for RDS, credentials for Documents DB, for Redshift, for other database or other type of secrets, right? So if it is for RDS, then I will specify a username and a password, all right? And then if I have a database created here, then I should be able to see the database here and then select it. Okay. And then the encryption is also managed by AWS. So it's an AWS managed key, right? Or I can set a customer key. So I can just add a new key and then create my own managed keys, right? And then use that. So that is also for secret management. So it's just like parameter stuff, but the difference is that there is automatic rotation. So if I was able to do this, it won't let me move forward, right? I can configure the secret. That is the however I want it, and then also configure the rotation as well. So you can see the rotation is even optional, but you can still configure the rotation. I'll review and then create it, right? Better safe than sorry. So we'll not do this. All right. But that is just basically about secret manager. You can also have a multi-region secret, right? So the same way, if you have a multi-region database, right, you have an RDS, a multi-region RDS deployment, then you can have your secret, the primary, and then it is replicated in another region, right? And then you are even able, this is mostly for disaster recovery, right? So you are able to promote the replica to what? A primary secret in case the region, the primary region goes down, and then you are switching to what? The secondary region. You are able to also do that with secret manager, right? So these are basically some of the security measures that you can also take. So we come to certificate manager. So anybody who is familiar with website management, right, or hosting management, the SSL store, the Let's Encrypt, all those people, they all provide what? TLS certificate. Okay, so that is what basically AWS Certificate Manager does. All right, that's what AWS Certificate Manager does. And then the beauty of AWS Certificate Manager is that it's able to also integrate with these other, so you can probably get a certificate from the SSL store. You can get a certificate from Let's Encrypt. Let's Encrypt they are public certificate, right? You can get them and then import them into AWS Certificate Manager, right? Then you use it to encrypt most of the times with your for your web service, right? So if you are serving a website and then you would want to encrypt your data in transit or in flight, then you can have your certificate manager, right, integrated with your load balancer. Since the load balancer is the service that is fronting your AWS or your web server, then it is wise that you integrate the certificate manager, right? You generate a certificate from AWS certificate manager, assign it to the application load balancer, and then customers will be able to communicate via HTTPS. All right. There is also another way you can do HTTPS redirect. We'll see a slide on that, but it just popped into my head. So you can also your customer can visit your website via HTTP. All right. And then you can set an HTTPS redirect. So anytime a person visits HTTP, there will be a redirect that, hey, you have to communicate with this server via HTTPS. So the connection will come back to the customer, and then now the communication channel will be rerouted through HTTPS. All right, and this is also done by, it's possible by the certificates manager, right?
Isaac, one question.
Yeah.
Okay, so for instance, if you are hosting a website, be it
Right.
static or dynamic. Let's say static on X3, then
Right.
dynamic on maybe an EC2 instance. Is it possible to acquire an SSL certificate from this AWS certificate manager?
Yes. So if, for example, if you are serving a static website, then it means the certificate is you have to use a cloud font distribution, right? So the
Yeah.
certificate, yes, the certificate will be applied on the cloud, and then the cloud front will front your static website, right? And then if you are hosting a web server on EC2 instance as a dynamic website, then it has to be fronted by. So you can see here it says you cannot use ACM with EC2, right? Since the certificate cannot be extracted, right? So it has to also always be fronted by either an ALB, CLB, or an NLB, or even an API gateway. Somebody's mic is doing maybe your mic. Maybe for plug and well. Still low. Still they do.
Hello?
Uh-huh.
Can I do what? Okay.
You go buy Panla microphone.
Okay.
But if they JBL, they
You
do
know,
like that.
I use Bluetooth headset. You get ANC, you get all the features. The Bluetooth sound be like
You can do
5.0.
Right.
It
So yes,
should, it should be.
if you are hosting the site on an S3 bucket, it's possible. But yes, it has to be fronted by a platform. We'll go into the best. There are some standards that we have to, that are defined. So we'll go into those, right? So how do you? So this is where I wanted to bridge it. So how do you request a certificate? So just like the SSL store, right? You first list the domain names, including all the, when you say a fully qualified domain, like if you have something dot your company.com, or you can do a wildcard, so star dot your company.com. So it means that anything that comes before the your company, you can request a certificate for that, and then you have two validation methods, either through DNS or email validation, right? So for DNS validation, it will leverage what we call the CNAME. CNAME is what is canonical, right? The CNAME record to your DNS configuration. So for example, if you have Route 53, then it will check the CNAME records that you have in what's it called, Route 53, to validate. If you are using email, then they will check the email through your Whois database, so the owner of the website. If the email that you provided is listed as the owner contact details, then they will do that validation. They will send you all these things, and you will do it. It takes some few hours to verify, though, right? I saw Bridget doing one some other time, so that's why I wanted her to explain anyway. So when you get it, then the certificate will be enrolled for automatic renewal. And then the beautiful thing about certificate manager is that when you generate the certificate with ACM renews the certificate 60 days before expiry. So it gives you like freedom. You don't even have to think about it, right? About the expiration of your certificate and then all that, right? But if you have an imported certificate, then there is no renewal. But however, ACM itself sends daily expiration events starting 45 days prior to the expiration. It doesn't automatically renew for you, but you have the privilege of getting notifications of expiry 45 days. And then you can also configure the number of days yourself manually, right? So you can integrate it with InvertBridge, and then which will be able to integrate with either SQS or SNS or Lambda to automate the renewal for you, or SNS to get a notification on your phone, and then you have to probably request for another certificate and then import them back to renew, right? So, and this is done through AWS config. So AWS config is able to, there is a manage rule that enable you to check for expiring certificate, and then you configure the number of days for, the notification. All right. So this is, as I explained earlier, how the redirection works. All right. So your front end application itself, you want them to visit the site via HTTP. So they type HTTP slash your website.com, and then the load balancer, because there is a redirect, the load balancer will now send a redirect request to like, hey, you will have to communicate. But these things are done automatically, right? So if, let's say, google.com, right? I am visiting http google.com. All right. Hey, and then I'm type here. Okay, so probably Google has also bought that domain as well. So you realize I didn't even type the full name, so probably they bought that domain as well. So even though I did an HTTP, but the result is what? HTTPS. So that is this scenario that we are looking at. This is what happened, and these things it occurs very fast, right? It occurs very fast. So these things are done automatically. So the same thing with Route 53. Let me even use this concept to explain Route 50. So the same thing with Route 53, right? So Route 53 has the server details and then all that. So if I should visit, somebody bring another website. Right. Okay, so let me just use the same Google, right? So if I should visit google.com, what happens behind the hood or under the hood is that this one queries a DNS server and say that, hey, I want to go to google.com. And then now Route 53 will tell me, so the request that I made, that, okay, you can find google.com on this server. Maybe go to this server A. This server A has a list of the IP address that directs to google.com. And then now, I will now, or the whatever I am using, will go to the server itself. So it is not Route 53 that is taking me there. So some people, when they are drawing the architecture, you see Route 53 will be in between. Or Route 53 stays somewhere. You go and ask for where the server is. It's just like you going to ask direction from somebody, right? And then it will send you there. So the same thing, if you have redirects, this is what happens, right? So a certificate is here, and then you have done an HTTPS redirect. So the person visits via HTTP. The load balancer response that you have to communicate with HTTPS, and then the connection now redirects via HTTPS, and then you're able to access the application. All right. And then it is also, so the same thing on ACM. ACM also integrates with API, right? The API gateway. But there are, and then API works with endpoint types. So there are different endpoint types that in API gateway. So it's just important that we know. So there are edge optimized, that is the default, and it is mostly for global services. So if you have a worldwide, a global website that serves like a worldwide, so for example, like Google, everybody accesses Google, I think, except China. China still use Google, but just some applications that they don't use, right? Now, what happens is that these APIs or whatever it is will be placed at edge. But what is happening is that it doesn't mean that it is the API gateway that is at the edge, but then the request is under the hood or somewhere. CloudFront is taking advantage of CloudFront locations, right, to improve latency so that you don't have to even though our access to the Google server has a little latency, if it takes maybe a milliseconds for somebody in the UK or the US to access Google, it will take us about 15 milliseconds, right, to access it. But what is happening is that there are cached content at these edge locations, right? So if not, the latency to even access some of these websites is going to be huge, right? But the API gateways of the original gateway itself stays in one region, but these API calls are cached at the edge. And there is also regional. This is for clients within the same region, right? And then probably can also manually combine with CloudFront, and then you still have control over the caching strategies for these kind of distributions. And then there is also the private endpoint where it can only be accessed in your VPC, right? And then that one takes advantage of the elastic network interface, and you will have to use a resource policy to define the access. So I think by now we have been mentioning resource policies. I think by now everybody is privy or understands what a resource policy is. So this is just a diagram as to how it works, right? So you might be serving a content, right? And then which is fronted by an API gateway as well as a CloudFront distribution. So the request comes through the API gateway. The API gateway queries the CloudFront distribution, right? And then the certificate also, and then before you are able to get access to it. But then this diagram is just to show how it's integrate with the API gateway. All right. So this is the what's it called? The edge optimized example, and then the original example as well. All right. Web application firewall. So the web application firewall works at the layer 7. Yesterday we were talking about, I think we briefly talked about, okay, that was after the meeting was done. Works at the layer 7. So the layer 7, that is where HTTP sits. Okay. And then what happens is that it protects you against these common web exploits. So you can deploy a web application firewall on an application load balancer. So here we have to remember this, right? Network load balancer doesn't sit here. The network load balancer works at layer 4. Okay, that is a transport layer, and that is TCP UDP. So you deploy a web application firewall on an application load balancer, an API gateway, CloudFront, AppSync GraphQL API, and then a Cognito user pool. So this one, we have to take notice of this, right? So with web application firewall, you are able to set up what we call the web access control list. And then there is IP set where you can have up to 10,000 IPs, right? So you can choose to allow or block these IP addresses, right? So if there are some known IP addresses that you think, are scam or bots kind of thing, you can use the IP set to limit that. I think it should be, let me check. Oh, it was my AWS account that I navigated from. I'm just hoping it doesn't log me off. Okay. And, let me search for WAF. I think WAF have been integrated with Shield. Yeah, so you have WAF and Shield. All right. So if you open WAF, you are able to create a web. I didn't look at the pricing. No. Let me show. So pricing, yes, you are charged per ACL per month, right? And it is prorated hourly. And then you are charged $1 per rule per month, and then 6 cents per million requests. But I think I will only be charged if I create it. Okay. So the resource type could be regional resources. So application load balancer, API gateway, REST APIs, Amazon App Runner Service, AppSync, Cognito user pools, and then verified access instances, or it can just be a CloudFront distribution. So if I should, okay, it will reload, right? So I can set a name, and you can see this one is global, right? So I can set a name, the description, if I want a metric name, and the body inspection. So here, if probably the request is more than, or it's up to 16 kilobytes, then, right, so limit 16 over 16 kilobytes, okay, cost, all right. And then I can add like the AWS resource. So if the CloudFront is fronting maybe an S3 bucket, a website in an S3 bucket or an EC2, then I can specify that here. But I will not do that because I don't want to pay. All right. So the common exploits are kind of SQL injection. So you can have like some scripts, scripts to put in there, those that are used for SQL injections or what we call cross-site scripting, right? But basically, web application firewall is used to protect your website against common exploit. And in the exams, you are going to see stuff like SQL injections, cross-site scripting, or you want to block certain IP addresses or block certain countries, then you can use what we call the geo match, right? So a geographical match to block certain countries. And then you can also even do a rate-based rules. So if, let's say, a certain IP address requests something or does an API call for more than 5 times, then block that IP address. You are able to do that. And then, but they are regional except for CloudFront. So if you are using it for CloudFront, then it's global. But if not, all the other ones, the other one where you can send it to either application load balancer and then all that are regional, right? And you can also set a group, and then this group are what we call a set of rules, like they are a set of reusable rules that you can add to a web application firewall access control list. All right, so you can create a set of groups that you can reuse for every ACL that you want to create, right? And that is a group. All right, so we are looking at how to also integrate. We are able to integrate it with an application load balancer. But then let's say you have a website that you want to integrate it with a fixed IP address. The load balancer doesn't give you a fixed IP address. It gives you what we call a DNS name, right? There you see the ELB dot something something. So if you want to have a fixed IP address, then you have to bring in what we call the global accelerator. Okay, you could have a network load balancer could have helped because the network load balancer has an IP address, but WAP does not support a network load balancer. So you have to front your load balancer with a global accelerator that will give you a fixed IP address. So here you can do a DNS to direct it to direct the clients to the global accelerator, and then now the global accelerator access the traffic from the application load balancer that has a web ACL, okay, which should be in the same region with the load balancer. The web ACL access control is attached to the load balancer before they are able to, reach the EC2 instance. Okay, so sometimes when you are visiting a website or a service, then you can see, sorry, this service is not available in your country, right? They are using GeoMatch to do all those things, right? Even on your app store and in the Play Store, if you want to download certain applications, they tell you this app is not available in your country. These are the dynamics that goes on. Shield, CCP will be hearing shield, DDoS attack, DDoS attack, DDoS attack, right? That is shield. And then shield is automatically activated for every AWS user, except for the advanced that you will have to pay for. You have to pay 3,000 USD per month, and then it's a subscription based. So immediately you hit on subscription. Let me go to the console. So if I should go to Shield, getting started, you can see if I should subscribe to Shield Advanced, if I click, I'm going to pay 3K per month. All right. So what Shield does is that, a DDoS attack is where there is multiple requests coming from different locations or different servers attacking your server, right? So you have a server here, all right, and then there is a distributed DDoS attack. So you have legit clients here who are trying to access your server or your website, and then you have plenty other bot servers who are also sending request, right, to your server. They are just sending requests to your server non-stop. All right. So this means that the server will have to respond to all these people before they respond to you. So at the end of the day, you will be here, right? And then you are not able to access the server. The server might even be overwhelmed with the request and might crash. All right. So that's what we call DDoS, right? DDoS. So it could be like multiple visits. So you have your probably a popular website, and then you can see that like plenty people are visiting, and then at a point you see you cannot reach a server. It's because probably there is a DDoS attack on, and even the normal website sometimes it happens. I remember Sakode was doing a program with which was being hosted on Seek. Okay, that was the first time like Ghanaians have heard of Seek, and within the first hour of lunch, the site went down because a lot of people were trooping in there, right? Trooping onto the website. So they didn't anticipate this number of traffic. All right. So by imagine, let's say it wasn't the case of legit users trying to access it and it was a DDoS attack. That is how the whole DDoS attack thing is. Okay. So Shield protects your infrastructure from these. And then if you want extra protection, right, on your services, then you can subscribe for the DDoS Shield Advanced. It gives you 24/7 access to the AWS DDoS teams called DRP, right? That is in case you are being attacked through you are having or you are experiencing a DDoS attack, then they can take you through as to what to do. And then in case you incur higher fees during the attack time, I think there is a provision for you to get a refund or something of that. They are able to review and see when the attack started and then the charges that you incurred during that period, and then I think you're able to get your refund also. All right. And then it also gives automatic DDoS mitigation. So at your application layer, Shield Advanced has the capability to mitigate this attack by creating and then evaluating rules, right, to check all these things. So Firewall Manager here is a service that allows you to create collective rules. Let me put it that way, right? Across your accounts under AWS organizations. All right. So instead of you to create a web application firewall rule, right, per account, if you have all the accounts under an AWS organization, you can use Firewall Manager to create a single web application firewall rule, and then this will be applied to all your resources, and then all in each account under the AWS organization, right? So the WAF rules, including application load, which you deploy on an application load balancer, an API gateway, and then a CloudFront. And then the beauty of it is that any new resource that will be created after you create this rule will adopt the rule. All right, it will adopt the rule. So the same way you're able to create Shield Advanced rule, you're able to create security groups for your EC2, your application load balancer. So instead of you going to security, creating security groups and then all that, you can use the Firewall Manager to create a security group rule, and then each application or EC2 instance that has been created is going to adopt that rule. The same thing with a network firewall at your VPC level, your Route 53 resolver DNS firewall, and then policies that are created at a regional level. So let me go to the console if it is something that I can do. What is it? Let me close this. So Firewall Manager, let me go to getting started. If you have to subscribe there, we'll go back. Oh, okay. So if I should creates this one too, I'll pay $100 a month. Okay. Right. But then that is just the explanation. So I think if I should go to application list, let me see. Okay, I still have to. Anyway, let's go back. All right. But I believe we understand. So for each of these services that we are able to create separate rules, or we are able to use it separately in our individual account. If we have, let's say, 10 accounts, and then we have it all under AWS organization, then there is no need for the individual account holders, right? So you have a development team, you have a production team. There's no need for each of them to actually like do these rules individually. We can set up these rules, and then for any resource that they create, they are going to adopt it, right on creation. So the difference between WAF, Firewall Manager, and Shield. Okay, so WAF is for protecting your servers or your applications against common exploits like cross-site scripting, SQL ingestion, and then all that, right? And then Shield is for protecting your applications against what? DDoS attacks. Now, Firewall is like a central management tool for all these services, where you create like central rules. Okay, you create central rules for multiple accounts, right? To adapt these configurations that you've created in both WAF and then AWS Shield, right? But then if you just want a single protection, like a streamlined protection against a single protection against your resources, then using WAF alone using the Shield and then WAF alone is okay, right? Is okay for you, because you don't even have like multiple accounts to manage, so that is okay. But if you have like the bigger organizations, and then you don't have, probably you don't want them to, you want to have central rules, right, that every services or every account under them adapts, then it's recommended that you use the Firewall Manager, right? So these are the best practices that I said we will get to, right? The best. So for DDoS resiliency, so you can see these diagrams has numbers on them. So the best practice 1, best practice 2, best practice 3, and then all that, right? So for DDoS resiliency, for your resources or your applications or your architecture to be resilient against DDoS attacks, then it is recommended that one, so we take it from here, right? That one, you front your applications, right, with what? A global accelerator, and then a Route 53. So you can see here, let's look at the Route 53 that I talked about. You can see that Route 53 is in the middle, right? So if we take from the DDoS point of view, it means the direction goes from here to here, right? Okay, so if we take it from the DDoS point of view, then we are looking at from here to here, all right? The CloudFront also comes in there, but basically it's here. Either you are using the CloudFront or you are using what? A global accelerator. So you can see the DNS query. So if, let's say, you want to go to example.com, right? The user will first query from the server here, and then Route 53 will give the user the address to go to, right? Before the request now comes here, goes this way, and then now to the application, all right? So for best practice against distributed denial of service attacks, is either you are fronting your application with a global accelerator, or a CloudFront distribution, and then you use what? A Route 53. So it means that before the request even gets to the load balancer and then to the application, right? Before the request gets to the application, it will either be, because Route 53 also has the capability of DDoS attack mitigation. Global Accelerator has it. CloudFront also has it. So it means that if it is not even dealt with here, it will be dealt with here before it gets to what? Your application itself, right? So this is for best practices for resilience against what? DDoS attacks. So this diagram and then all these technical things is just what I'm explaining, right? And also for okay, right. So for this is for what is it called? Before it gets into your infrastructure. Now, for your application structure, also the same thing. Here you have your application fronted by what? A load balancer, and then also fronted by an auto scaling group. So what this means is that in case these things are also not dealt with, and then they come here, the DDoS attacks comes here, the load balancer, the auto scaling group is able to what? Launch more instances depending on your auto scaling configurations, right? To accommodate, yes, that you are going to incur charges. But as I said, if you are subscribed to Shield Advance, then you are assured that you are going to get your money back, right? So the auto scaling group is able to scale resources to meet the demand, and then the load balancer is also able to what? Balance the load or distribute the load evenly, right? According to the demand that comes, right? So that is the best practices. So probably you might have a question that a company has a DDoS or faces DDoS attacks or suffers DDoS attacks. And then as a solutions architect, you are hired to give them the optimum solution to do that. So what you can do, probably definitely you'll see front the application first, put your instances in an auto scale, but most of the times they are going to ask you from here, right? I mean, the best practices outside the infrastructure itself. So you front your applications with a load balancer, front it with either a global accelerator or a cloud front, and then have Route 53 also there, right? And yeah, so this application layer defense. Okay, so for application layer defense too, you can also use what? WAF. So you look at certain IP set probably after your audits, and then all that you realize that okay, a certain group of IP addresses access are the ones that are doing that. Then you can use WAF to what? Create an IP set rule, or you can even create a security rule, right? And then make sure that all these are taken care of, right? You can also use Shield Advanced, and then Shield Advanced will give you protection for both best practice 1, best practice 2, and then best practice 6, right? That is for load balancer as well. And then for reducing your attack surface reduction. So it's just multiple, you are looking at having multiple combinations of, so you don't need to actually have all of these, but you have like multiple combinations to, reduce your attack surface, or to reduce how exposed you are to DDoS attacks. All right. So you can probably have Route 53, and then you have WAF. So WAF will check your IP address, your geolocation, or whatever it is before you hit the cloud front, before it takes you there. If you are making API calls to check, like for authentication, right? So before it takes you there, or you can use Route 53 fronted, and after that fronted by a global accelerator before it takes you there, and then in your infrastructure too, you have a load balancer, and even first you are into a VPC, where this is where security groups and then network access controllers are all here, right, before your load balancer. So you can have like multiple combinations of infrastructure to help protect you against denial of service attack. Please, Mumbisa questions. Or we are all okay.
Is everybody awake?
Asem so na webisa no.
Richard bet. Ah,
Richard, he taps more or then in the bed. Okay, so
come on, sir.
okay, so let's look at guard duty. So from CCP, we learned that guard duty has a 247 monitoring, right, on our AWS resources or on our infrastructure. And normally, what happens under the hood is that it uses some machine learning algorithms, right, to detect anomalies or any third-party data. And you don't need to actually install any software. It's also a one-click to enable, and then you have 30 days trial, right? So it is able to check your CloudTrail events logs, your VPC. So we have to also take notice of this, right? Your CloudTrail events logs, your VPC flow logs, and then DNS logs. Guard duty does not check CloudWatch logs. All right. So yɛmfa no nso into yɛtirim. Guard duty does not check CloudWatch logs. It's CloudTrail events logs, VPC flow logs, and then DNS logs. There are optional features to check your container logs, that is EKS logs, your RDS, Aurora events, S3, and then Lambda, as well as S3 event. So you can also set up event bridge rules, right, to be notified in case of finding. So in case it finds any anomaly in any of these logs that is checked, then you can set up event rules to be notified, right, in case of any findings. And then, as usual, event bridge integrates with Lambda or SNS. So it can invoke a Lambda function to automate whatever you would want it to do, depending on the anomaly that it detects, and or also get a notification. And you can also use guard duty to protect yourself against cryptocurrency attacks, right? It has a dedicated finding feature for it. That's for guard duty. So this is how guard duty also integrates with the services. So you have the VPC flow logs, the CloudTrail logs, and then the DNS logs, and then other optional features. And then the optional features, they can increase, but then for logs, guard duty does not check CloudWatch logs. So let's take note of that. And then for the what we read theory is what you are seeing in the diagram. So you can integrate with Event Bridge, which can send notifications via SNS or use it to trigger a Lambda function for automation. Inspector is for security assessment, and then it's run when needed. Okay, it's run when needed, and then you use it to check your EC2 instance, and it leverages a systems manager agent, right, to analyze against unintended your network accessibility. So if we talk about unintended network accessibility, we are looking at when probably you have opened a security port, right? You have opened a port for everybody, or I mean, yes, you are opening up for vulnerability. Okay, so inspector does that and then gives you a recommendation as to, or alerts you as to what needs to be done. And also it also integrates with events bridge, or the findings can be sent to security hub. I think yesterday when we were looking at the questions, we saw a question like that on security hub, right? You can also use it to analyze your operating system, right? Your OS that you are running, and then for you to check against some known vulnerabilities. It can also be used to inspect container images that you push to ECR. So the assessments like is done whilst the containers are being pushed. The same thing is, it can also be used to check your vulnerabilities in your function code in your Lambda package. So if you write a function, if you write a code that you want to deploy with Lambda, you can use inspector to actually check for vulnerabilities in the code and the package as well, right? And then the assessment is done when functions are being deployed. So when you put your code in Lambda and then you click on deploy, whilst it is deploying, the inspection is also done. And they were spoken about the fact that the reporting and then the integration, it's able to integrate with Security Hub, and then as well as you're able to send findings to Events Bridge. All right. So as I said, the inspector does the scanning of the infrastructure when needed. So it's more or less like on demand, right? When you need it, it does that. And then for checking package vulnerabilities is EC2, ECR, and then Lambda. And then it does that through what we call a vulnerability database, that is CVE. So there's a database of vulnerabilities that inspector uses to check against your resources. So in case the CVE is updated, inspector is able to use the updated database, vulnerability database, to check against your resources, right? And then there is a risk score that is associated with all the vulnerabilities for prioritization. So depending on the type of vulnerability that you have, there is a score that is attached to it, right? For you to prioritize what to work on and what to actually ignore. MASI is short, right? So MASI is a data privacy service, a security or data privacy service that also uses machine learning and then some pattern matching to discover and protect your sensitive data. And then the sensitive data are personal identifiable information. Talk of your security, your social security numbers, your credit card numbers, your health records, and the phone numbers, your house addresses, and then all those things, right? MASI is just the service for it. So you can have the data in S3 buckets, and then you can have MASI deployed on it to check for this sensitive data. And once again, it can integrate with Events Bridge, which can then integrate with other notification service to send notifications. So that is it about security and encryption in AWS, all the security service that you can find in AWS. Please, any question? And let's see those who are actually online and not asleep, so that we'll look at the questions under them. So I think as the question comes, we should be able to have the understanding better. If we don't have a lot of people online, we'll end it and then we'll look at the questions tomorrow. There are 25 questions, so I don't want it to go waste. If they were, if they were like some 5 questions there, then that's fine. But 25 questions there. I don't want
Guys, if you do online, make you know how many people do online. Type something or say something.
to type something or say something. Let me open the chat. Sita
I
is
go.
Sita is online.
That's just
All right. So to enable in-flight encryption, that is in transit encryption, we need to have so go do A, B, C. All right.
they say zoom in small. But
Is
you
it?
can try zooming on your machine.
Make you bring answers. Make I bring the chat. I've zoomed in. Or make I bring the slides up so say you people go read them, go select your answer.
But I say you get the 65 questions in 6 parts one.
I no get, but somebody gets.
Ah, okay. So if I get that one, I figure that be then that be already kind.
No. This one be like specific questions under security.
Oh, okay.
Only one answer come. I foresee like 7 or 10.
Chairman, yeah, there be now.
Into the 18th way.
It's as an it.
Let's
Okay.
not tell you chinguana.
Okay, so server-side encryption means that the data is sent encrypted to the server. Aha.
False. Yeah, most I it's the key to know.
Hey,
Hey, Derek F.
back up about F for
I say
false.
F for false.
Oh, okay.
In server-side encryption, where do the encryption and decryption happen?
Seven are encryption. Both encryption and decryption happen. Both encryption and decryption.
Mutia na chese me na manchra de ni.
Oh yeah.
Naya bon.
Encryption depends on the client.
There be one more I'm ready fi. Ah, AK, where's your answer? Bridges still did a caught up. Hey,
Yeah, see.
I didn't know na move CC sir. Steve when you
Wrong.
Steve when you what
Wrong.
team?
Wrong. Selection.
It be wrong. So server-side encryption, I explained say on server-side encryption, the encryption happens on the server, right? And then the message is sent unencrypted to another server, and then the other server decrypts the message. So both the encryption and then decryption happens on the server side. The client, yes, the client is not involved. Okay, so this is what I said. Let me see if I can draw on this. Okay. So I did something like this. So your server is here, all right, on the server side. And then you send a message here to another server, right? So if the message is encrypted on the server side, when it gets to the second server, the second server will now be able to what? Decrypt the message. And I explained client side. So for client side is the same thing, but this thing for client side, the server does not even see the key. So both the encryption and then the decryption is also done on the client side. So you don't have a situation where encryption will be done on the server side and then the client will have to do the decryption. You're either doing a server side encryption or a client side encryption.
So hold on. Make I understand something. If
right.
the client sends the data to the server,
right,
not encrypted data to the server, and the server encrypts, and then there's no like communication between that server and any other server, but the client requests that data back to that same client, what happens?
Right. So it's like you accessing a website. You understand? It's like you accessing a website. Now, when you enter your logins onto a website, what is happening is that data, when you type the logins and then you click on sign in, that data is encrypted and then sent to the server or the database server. Now, the database server will be the one to decrypt the message. You understand? So you at your end, even though you are the one entering, but the decryption and encryption is not done by you. It's done by the server.
That be server-side encryption.
That be server-side encryption. But for client-side is when I have a document and I'm sending it to Prince.
And then you encrypt it.
And then I encrypt it. So for that one, if I send it to you, I'll have to send you the encryption keys.
The public key or
the public and then the private key for you to decrypt it. So both encryption and decryption will be done at your side, at the client side. And if it's server side, both encryption and then decryption will be done on the server.
So there is no case where encryption is done on the server and then decryption is done on the client?
No.
Fine. Interesting. Who select the answer?
But then I'll select the majority. So say,
oh no. Abi, if
Let me
the answer
say
is correct.
Is there?
Let me say Yabon.
No.
No, we are born answer.
Yes, Yabon.
So with server side, both encryption and decryption happens on the server. I just they hope say go bring explanation. So in server-side encryption, we can't do encryption or decryption ourselves as we don't have access to the corresponding encryption key. So I even said that with server-side encryption, you are either using AWS managed keys or AWS owned keys. So the encryption is done on the server. So we don't see it at all. It is only when we are doing customer managed keys. Right? So even if we are doing customer managed keys, it means that for the services that will be communicating, we have to give resource policies or key policies, right? For these services to be able to use the keys to do the decryption. That's even server-side encryption by customer managed keys. So still, The encryption and the decryption is done by the server side. What you do is that you specify key policies for the resources that are going to use the KMS service to be able to what? Use the keys to do the decryption.
All right.
And but client side, you are even doing it outside. You do the encryption outside AWS, and then probably when you bring the data into AWS, still you will have to download it, right? So if, for example, if I want to send you a file to your S3 bucket, you are giving me cross site access, cross account access to your S3 bucket, and I upload a file in there for you. I encrypt the file off AWS. I upload it. When you download it, and then you do the decryption off AWS.
Okay.
That,
So we fit search maybe some Google a process where maybe the encryption happens on the server side and then decryption happens
on the client
on
side.
the client side. I want to see if it exists.
Yeah, make a.
I will record this part or
Yeah.
oh,
Or make a stopper. Okay. So data is encrypted before it leaves the client's device. For example, when you type "I am a dev" and click send, the text is encrypted. Yeah, I don't like this expression.
no, this one is confusing.
It's called no. This one too. The encryption process occurs on the client's device before the data is transmitted.
Nah.
No. So you see, the decryption takes place on the client side when the encrypted data is retrieved from the server. So I think
All right. So that means client side server
client side
I say
encryption.
client side server. Client side encryption. The clients do the encryption with on the client side. We use server side encryption down
But your line they
the
break.
server.
Prince, your line they break.
Did you hear me?
Yeah, how they hear you now? Or in my network rather.
Yeah, it seems like the internet is in the past.
So you guys can hear me.
Yeah.
Yeah, I go see.
Uh-huh. Because I don't say my internet before I started show.
I go see. I'll ban you.
So okay.
Isaac,
So for both of them, they both happen on each of them. Like
Yes.
there's no okay.
Yeah. Inti move on to mutrim. Okay. So in client-side encryption, the server must know our encryption key before we can upload the data. I mean, sure we so we'll be sure we are.
F for false.
All right. So yes, this is false. So with client side, the server also does. So the same way with server side, the client doesn't know the keys, right?
Yeah.
You need to create KMS keys in AWS KMS before you are able to use encryption features for EBS, S3, and RDS.
F for false.
Over some
False.
F for false.
one I can force.
Say please is me.
Why?
Because Y has a long tail. You
Because
can use the AWS managed services in KMS. Therefore, you don't need to create our own KMS.
yes. So AWS KMS supports both symmetric and asymmetric. 10 questions. Near upon.
You see, in your 5, what do you call 10?
This is the 6th question, sir.
That was here, got 10.
Okay, upon. I be if you want come on. Rubicon. Rubicon on part this year. You can't say your questions. So he's left.
You ran away.
All right, so this is true.
KMS can be symmetric or asymmetric. Asymmetric key represents 256 keys, function, and symmetric. KMS key represents the RSA key pair used for encryption and decryption or signing and verification, but not both. Or represents an elliptic pair key pair used for signing and verification. Oh.
Okay, guys, let's one more point.
We have got 10 problem. I started with that.
When you enable automatic rotation on your KMS key, the backing key is rotated every
1 year.
Akosiani.
So the answer they make binichimu.
Wedi baba.
Oh, you said it.
Yeah, so with KMS is 1 year, nothing less, nothing more. So you have an AMI. This one there. We na me say motiasi explanation na me motiasi ana. You have an AMI that has an encrypted EBS snapshots using KMS customer managed keys. You want to share this AMI with another AWS account. You have shared the AMI with the desired account. Excuse me. But the other AWS account still can't use it. How would you solve this problem? So the other AWS account needs to log out and log in again to refresh its credentials. You need to share the KMS CMK used to encrypt the AMI with the other AWS account. You can't share an AMI that has an encrypted EBS snapshot.
So you need to share the customer managed to encrypt it so that the other accounts can use it.
All right. So you have created a customer managed CMK, right, in KMS that you use to encrypt both S3 buckets and EBS snapshots. Your company policy mandates that your encryption keys be rotated every 3 months. What should you do? Wenso eno na be mehu se motiase ana amantiase. Move accessing, but let me reduce this take here. We menka okay, meka mo be hu. Because you bring answer.
I'm looking at B or C. Okay, C.
Why C?
Because you know, like for the A, you said we can't change the KMS. It's 1 year, and we can't change it from 1 year.
I'll buy you biscuits. Okay.
Yeah.
So if you got the other question right and then you get this one wrong, then it means Uchaloto. So that is it. So with KMS, you can't rotate the keys any like lesser than 1 year or more than 1 year. So if your company policy mandates that you rotate your keys, then you have to rotate the keys manually. You create a new KMS key and then use key aliases to reference the new KMS CMK, right? Keep the old KMS key so that you can decrypt the old data, right? Good job.
But can I ask something?
You can yes, you can add.
So you mentioned another service, and then that one we can set the rotation period like by X. So if the question had something like with the least operational overhead, because the C looks like a lot of work.
Right.
So can you go for like why? So can you go for that service instead?
So for that service, it's for secrets, right? It's for that's the secret manager that I mentioned. So they are for credentials, passwords, and then all those stuff, right?
Okay.
So for KMS and then customer managed keys or AWS managed keys, if you want to rotate your key for lesser than 1 year, then you will have to think of managing your keys manually, right? So for for secret manager, the credentials are encrypted, right, by KMS. So the automatic, what's it called, rotation involves both the keys and then the credentials as well, the secrets that you have stored as well. Does that make sense?
Yes. Thank you.
You're welcome. So I mean, with this, if you have this in mind, definitely when the question comes, you should, I think you should ring a bell, because definitely the question won't come raw like this, right? When it has to do with secrets manager, the question won't come raw like you have created a customer. You know, this one was specific on the fact that you created what, a customer managed key, right, in KMS. Yeah. So what should you use to control access to your KMS customer managed keys? This one there is a very good question for climax. Fala way.
Access, they say policy.
Yeah, key policies.
So why not IAM policy? Why not KMS IAM policy?
KMS IAM policy. Like, to control, you're looking for what you should use to control access.
Right.
Customer managed. So, since key policies are there, I was like, I don't know why I would go for IAM policy.
So why not KMS access control list?
I didn't hear you mention KMS access control list.
Yeah,
I
so there's
remember.
there's nothing like that. And then there's even nothing like KMS IAM policy.
Okay.
But the question is not canon. But yeah, man, they make we continue more. And I am favor to us.
Make we vote.
So I was going to say tomorrow.
Yeah, I feel like.
Because the more we answer, the more we learn.
Yeah.
Ana must say may I invite me if you want me to. See that should we continue? Should we continue? Should we continue? Just
Yeah,
to answer.
we can continue. But how many hours?
Was it, eh?
Send a link to today's recording. Why? Couldn't join the session early. Also,
I think Robin was not here. Yesterday's one,
Charlie,
I haven't shared it.
yeah, can I edit it? You know.
Yeah. The one you put this, your.
You insult them like that.
Okay.
So make I send you it so that because not she know the response.
So guys, should we continue?
No. You know,
And start here fresh now.
Yeah. Go with tomorrow. Charlie, make I upload. More, I go upload today's one. I go upload tomorrow, but I go try upload yesterday's one today. All
today you
right.
know get right open.
No, my light's there on.
I pray for the mood, bro. Oh, sorry, why?